All right, I'd like for you guys to do the roller coaster activity before watching this lesson. So if you haven't done that yet, do that real quick. Let me come back to this. All right, so topic 2.3 and 2.4 over continuity and differentiability. So pretty much if the function was a roller coaster and at a point if it would cause the roller coaster to wreck or cause you to die while riding the roller coaster, the function is not differentiable at that point. So for a function to be differentiable at a point, we'll call that point A. The function must be continuous at that point, and the limit as x approaches a from the left of f prime of x must equal the limit as x approaches a from the right of f prime of x. Now remember, f prime of x is the derivative, so for a function to be differentiable at a point, the slopes must match from both sides. So that's where on that roller coaster ride, if you ever had a sharp angle, that's because the slope from the left doesn't match the slope from the right. All right, so non-differentiable functions at x equals a could be not continuous. So it could be that f of x is not continuous. At x equals a. So I'll just do a few graphs where that is the case. So here's A, so your graph could be coming along and then all of a sudden you have a hole in the graph. That function would not be differentiable at x equals A, right? There could be a jump discontinuity at A, so your graph could come, there's a hole, and then pick back up somewhere else. That's going to be not differentiable at A because it's not continuous at A. Or you could have a vertical asymptote at A. So your graph could come and then go towards infinity, go towards negative infinity at A. So those are some examples of the function not being continuous at A, therefore not differentiable at A. All right, it could be a situation where the slopes from both sides don't match. Right, that's when you get kind of a sharp turn. Right, that function would not be differentiable at A, even though it is continuous at A, it's not differentiable at A. And then the last situation is when the slope is undefined. So if you think about when a line is undefined, a vertical line is undefined. So if you have a vertical tangent at A, then that function is not going to be differentiable at A. So it's coming up and then it goes straight up and then continues. That's a vertical tangent. All right, so the function is not going to be differentiable at x equals a because of the vertical tangent line. All right, so for example 1, we have g of x and we have h of x. We are going to list all the points in the graph at which the function is not differentiable, and we're going to give the reason. All right, so I'm going to start at the left. We're good. We have a straight line. It's all continuous until we get to the point -2. So when x equals -2, the function is not the function is not differentiable because the function is not continuous there. So our reason would be g of x is discontinuous at x equals -2, because there's a hole in the graph. Okay, so we're riding along in the roller coaster and we're doing good until we get to this point where you would wreck. And this is the second reason. So slopes don't match. So I'm going to write it like number 2 up there. For the reason, we would say that the limit as x approaches 2 from the left of g prime of x doesn't equal the limit as x approaches 2 from the right of g prime of x. So that's the calculus words that you write for sharp turns. All right, and then we're doing well until we get to 4, and it's so steep that they would probably cause the roller coaster to wreck. Now, I did ride a roller coaster in Universal Studios that pretty much went straight up like that. And it didn't wreck, but it's not going to be differentiable there because there's a vertical tangent at x equals 4. All right, so you guys try to do B on your own. So this one is h of x. So just pause the video, try to do it on your own, and then pick back up. All right, so this one, if we start from the left, the first place where there's an issue is going to be when x is -5. And that's because h of x is discontinuous at x equals -5. Okay, so we don't get very far and we have another issue, and that's when x is -4. And it's the same reason as -5. H of x is discontinuous at x equals -4. Okay, and if you're riding the roller coaster, the last place where it looks like there's going to be an issue is when x is 0. So anytime you see that sharp turn, the function is not differentiable there, and the reason is the limit as x approaches 0 from the left of h prime of x does not equal the limit as x approaches 0 from the right of h prime of x for that sharp turn. Okay, the next 4 problems we're going to do, for example, 2 and 3, we need a graphing calculator. So example 2 says to use a graphing utility to graph the function and then find the x values at which f is differentiable. Okay, so we're going to start with the graph. Okay, I'm going to just change the window just a tad. Oh. Okay, so this is the type when you have something raised to the 2/3 that I like to say looks like a bird flying, like when I was little drawing bird flying in the sky. So because I have that sharp turn at 0, that the function is going to not be differentiable there. So everywhere except there. So that is going to be from -infinity to 0, but we don't include 0, so we'll do a parenthesis, and then we're going to pick back up at the other side of 0 to infinity. All right, now one thing that we haven't done in the calculator or you haven't done it with me, is graphing piecewise functions, because last year we just did everything by hand. But the calculator will graph piecewise functions for you. So what you do is you go to y equals, and you type in the first piece, so x squared plus 5. All right, then you're going to do divided by, and then in parentheses, you're going to do x is less than or equal to 1. And then unless you write programs on the calculator, you probably don't know where less than or equal to is. But what you do is you go to seconds and then math. And it gives you the greater than, less than, all those symbols. Right? And then we need to do the other piece too. So we would do y2 equals, and then 2x minus 2, and then divided by, in parentheses, x is greater than 1. Okay, so let's type that in. Now don't forget about the divided by, and don't forget about the parentheses, because it will mess you up. So all of the greater than, less than, equal to, all that stuff is second, and then math. And this one is going to be less than or equal to, and 1. All right, and then we'll do the same thing. 2x minus 2 divided by x. Second, math, number 3. 1, and then close the parentheses. All right, let's look what's happening there. And you probably could have guessed it. I mean, it could have been connected, but this function is discontinuous at 1, but everywhere else we're in good shape. So we would say the function is differentiable from negative infinity to 1, and then pick back up on the other side of 1. Because we don't have anywhere where we're going to have a vertical tangent, and then we shouldn't have any other issues besides the discontinuity. All right, number 3 is also a calculator question, and you may not know this because I've never shown you, but there is a way for you to find the derivative at a point. So if we need h prime of 0.5, your calculator will do that for you. We're not going to get too dependent on it, just because sometimes you can't use your calculator. Sometimes, let me scroll back up and let you guys get that written down, sorry. Sometimes you can't use your calculator on the AP test. About more than half the time you can't. So we do need to know how to do these by hand. But when you can use the calculator, it's awesome. So the buttons you push to get to the derivative feature in the calculator is alpha, and then window, and then choose number 3. All right. Let's go back to the calculator. So we are going to find h prime of 0.5. So we're going to do alpha, window, and then we're going to choose number 3. All right. So that little flashing thing, we need to put in x, because x is our variable that is in the function. All right, then I'm going to type in the function. Now this is a pretty complicated function. We are nowhere close to being ready to try and do one like this by hand. And then if you need to see all the buttons I pushed, the way this program works, you can see the keystrokes down at the bottom. Okay, and then we're going to go over, and then whatever x value we're wanting to find, like h prime of 0.5, we would put the 0.5 there. And it will do it for you. Oh, that's not what I got before. Oh, it's because I didn't do 4x. All right, so we can go back up and choose it again. There you go. So you have to be careful, because if I hadn't already worked this problem out, I would have just thought that was the answer. And it wouldn't have been. So I'm going to write down the answer, and then I'll write some more things about the calculator for you guys. Now remember that we need to be accurate to 3 decimal places. So you can either truncate or you can round. So on this one, if you wrote negative 0.146, it's perfect, or negative 0.147 is perfect. There is no preference. You just either truncate or you round. All right, so I'm going to write down what it actually looked like when we typed it in, so that might help you later. So we do d over dx. You do have to put that x in there. And then you type in the function. Okay, and then at the end, you have to put in your 0.5. So that 0.5 has to match. All right, so you guys type in b on your own. So pause, type in b, and then pick back up with me. All right, so absolute value, you may not remember, is alpha window also is number 1. All right, so the calculator said that h prime of 0 in this case was 0. But I'm hoping you guys remember that the absolute value of x looks like this. Whoops. Is this function differentiable as 0? Oh, sorry. All right, that's what it looks like. Is that function differentiable as 0? Absolutely not. So this is not true. So sometimes your calculator lies to you, and I know it's frustrating. This is another reason why we can't be super dependent on the calculator, because it will deceive you. So h prime of 0 does not exist, or is undefined, however you want to word it. It's fine either way. All right, so we are going to also check these algebraically or calculusly. So to check differentiability, it's really common to use the second limit definition, which I think you guys like better anyway. So if we want f prime of a, and we want to use the second definition, we would have the limit as x approaches a of f of x minus f of a over x minus a. Now, remember, this limit definition can only be used if you're finding at a point. We can't use this one to find like the function for the derivative that you could use for any point. So it's easier to use, but it's a little bit limited. Okay, so on example 4 and 5, we're going to determine if the f of x is differentiable at different points. So for example 4, we're checking at 2, mainly because 2 is where you start using a different piece of the function. So first, we'll check to see if the function is continuous at x equals 2. All right, so what we do to check for continuity is we find the limit as x approaches 2 from the left of f of x. So that means I'm just going to take 2, I'm going to plug it into the first piece, and I'm going to get 5. All right, and then I'll check it for the second piece. So as x approaches 2 from the right of f of x, so I just take 2, I'm going to plug it in. All right, 8 minus 2 is going to be 6. So because I get different numbers, our pieces don't connect. So f of x is not continuous, therefore there's no way the function is differentiable. So we would say f is not differentiable at x equals 2 because f is not continuous at x equals 2. Alright, so we don't even have to worry about checking the second part. So for the function to be differentiable, we're checking that the function is continuous at that point and the slopes match at that point. So since the function wasn't continuous at that point, we're done. We can just say no. Alright, so let's look at this one. Since I have more space, I'm willing to bet we're going to have to do more work on this one. So let's start by checking to see if this function is continuous at 1. So let's just do the limit from the left. And we get 0. Alright, and then we'll do the limit from the right. And we get 0. And there's one more thing that has to happen for the function to be continuous, is that those two limits also have to equal the value of the function at 1. And because this one has the or equal to, we would plug 1 into that one. Again, we already did it, and we get 0. So the function is continuous at x equals 1. Yes, continuous. Okay. Then I'm going to have to check on the slopes from both sides. Alright, so we are going to check the limit as x approaches 1 from the left of f prime of x. Alright, so that's going to be the limit as x approaches 1 from the left. Now f prime of x, we're going to use that problem right here. So it's going to be f of x minus f of 1 over x minus 1. So that's going to be negative 1 plus x minus, right? Then when I put 1 in, I already know I'm going to get 0 over x minus 1. Now I cannot plug 1 in until I don't have x minus 1 on the bottom anymore. But what I can do is just, rearrange that so that it's still a positive x and a negative 1. So they completely cancel out. And when everything completely cancels out, because it's the same thing on the top and on the bottom, it leaves you with 1. Alright, so that is the limit as x approaches 1 from the left of 1. And so that's just going to be 1. Ooh. So the slope from the left side is 1. Let's check the slope from the right side. I'll write a note. Okay, so that's going to be the limit as x approaches 1 from the right of f prime of x. Alright, we'll use our second definition. So we're going to do f of x minus f of 1 over x minus 1. Okay, so this time f of x is 1 minus x squared. From that, I'm going to subtract f of 1, which was 0. Alright, this one we have a little algebra to do, more than just rearranging the problem. So I don't really like it that it's 1 minus x squared, so I'm going to factor out a negative, and then that's going to make the negative x squared positive, and it's going to make the 1 negative. All right, we need to do that to get to our answer. All right, and then that's going to factor to x plus 1, x minus 1. X minus 1's cancel out, so now I can plug 1 in. So it's negative 1 plus 1, which is going to give us negative 2. All right, so that means that the slope from the right is 2. All right, and obviously our left slope and our right slope don't match, so that's going to create a sharp turn. So what would happen is we have a slope of 1, and then we get to where x is 1, and then we have a slope of negative 2. That's going to make the function not differentiable at that point. So let's write that. So over here we have to answer the question. We would say that f is not differentiable at x equals 1 because the limit as x approaches 1 from the left of f prime of x does not equal the limit as x approaches 1 from the right of f prime of x. All right, and then we have this theorem that differentiability implies continuity. Now, we did a free response question from an actual test the other day, and I told you we were trying to determine if the intermediate value theorem was applicable, and in the problem it said f of x is a differentiable function, and I told you that that means that it's definitely continuous, so that's this theorem. So if f is differentiable at x equals a, then you automatically know f is continuous at x equals a. So the relationship between continuity and differentiability is that if a function is differentiable at x equals a, then it is continuous at x equals a, which is what was already written on the paper, but that's okay. We can write it twice. Right? But it is possible for a function to be continuous at x equals a and not be differentiable. And we've seen that a couple of times. It's not differentiable at that point. So we saw it on this one right here. The function was continuous but not differentiable, and we talked about what would happen is we want to draw it where it's not differentiable at 2. Continuous at 2 but not differentiable at 2. So we have a slope of 1, and then we get to that point, and then all of a sudden we have a slope of 2. So it's continuous, but it's not differentiable. Another situation you could have would be at 2 you have a vertical tangent. So it's coming up here and then it curves up and makes a vertical tangent line. So continuous at 2, but not differentiable at 2. All right. So that takes care of that lesson. Your assignment, there's a little half-sheet worksheet I want you guys to do. It's called Topic 2.4 worksheet. And some problems out of the book also. So on page 105, I want you to do 76 through 84 even, 88 and 89, and 94 through 96. And then don't forget about finishing yesterday's assignment because it's super duper important.